Hello everyone, in this tutorial we are going to learn about a step-by-step guide on how to clean your data and refine your visualization for meaningful insights in Databricks. So let us go back to the previous tutorial at the end of the section. Here it is. I'm going to start by click code in this cell. Step 1, I'm going to step 1 check your data ranges. First, inspect the data to understand what values are present. With this code, I'm going to print this. Oops, I got an error. Can you follow me? It's not finished yet. So, I'm going to see the issues to look for. A key error, IMDb score that is not found. My data frames columns, PDF, what columns that was loaded with no header. Columns are usually names. Let's print it out. Here's release year and average image score and D types object. This is up to object index. And from this source code, we will have to swap out the range of the PDF average image IMDb scores instead of the IMDb scores after having an error code. I'm going to click this again. Here is the count 310, unique 82, top none, frequency 229, and unique release year like none. Here's a none value, and 95, 0, something, something until 50.0. Average image score like this. Count is like this: mean, stand, minimum 25, 50, 70, max, average data. This is very useful for understanding what happening. What happening is here. IMDb score states this is average, count 1 to 4 entries, and the mean is about 10153, which is nonsensical for IMDb scores, which should range 0 to 10. Mean is 0, max is 75270.33. That is way outside normal. IMDb score indicates the data errors or misinterpretations. The release year counts 310 entries. The unique value is 82. Top value is none. They mean 2 to 9 occurrences. The indicates many missing or valid year. Other values include various years. Some are uninspected, like 3, 8, 35, and 50, something like that. What does tell us? This data for IMDb score is incorrect and contains huge outliers, likely because some columns contains wrong data or the columns was misinterpreted during load. The real years has many missing or invalid value. Many rows lack proper years info or have some corrupted data entry. So how to improve our analysis? First is identifying the actual column. Ensure you're working with the correct data. Maybe IMDb scores is in a different column or the data loading was wrong. So I'm start by click code and then print the F columns. I'm gonna click this one. So I'm using PDF columns, or I'm going to print. I'm not using the PDF. I'm using that one. Let's click this run cell. Is the index ID title. This is the first original data. I'm going to using this one. So step 2 is the data cleaning ideas. Filters out outliers in IMDb score. With this, printed the Python code. So this one, and switch this one. And print df underbar clean. And I'm going to remove or fix invalid release year entries. So df clean release year, here it is. It's changed as convert to numeric and set invalid to none. Pandas to underbar numeric. The cleaner, this one released underbar here, comma errors, copy policy. This is convert to numeric set invalid none. So I'm using this with keeping only years between reasonable range, like 902, 2002, 3. So after cleaning, redo your aggregation and visualization step again. So I run this cell. Oh, there is an error. This error happens because we are trying to combine multiple Boolean the conditions using a pandas syntax, like this one, directly on Spark data frame, which is not valid. Both Spark frame at this point is not pandas, so Spark data frames doesn't support Booleans indexing like pandas. Instead, you must use the Spark filtering. So I'm change this one like this. I'm using the filter methods, knowledge, and method or functions to filters out outlier in item score more than 0 and less than 10, and it converts release year and between something 19 to 23 using the F and the column for Spark data frames. So I click the run cell. This is good catch. The function is to numeric does not exist in Spark SQL and functions. So how to convert a columns to numeric in Spark? With this, I'm going to change a whole bunch of the Python codes into the complete filtering in Spark. There is no to numeric in Spark, and they're using the cast int to clean release year and using filter functions within the conditions combined with this one and f-column. This is a function in PySpark. After we finish the convert to columns to numeric in Spark, we're using that source code again using the df clean inside that one. So previous the process to convert X-ray column and remove header, assign actual, calculate average, and do clean like this and release year. After that is convert handling, and using the plot we show. Let's do it. This is correct visualization. So certainly here is an easy to understand analysis tolerate for your online students based on the line plot. This is the analyst trends in average IMDb scores over the years. What does this line chart show? It visualized how the average IMDb scores of movies or shows have changes over the different release year from the 1950s to recent year. First one is from the key observations. First, fluctuations over time. The trends line moving up and down, which indicates that the average scores have varied across the different periods. Second significant drop in 1978. The biggest drop occurs around 1978, with the average score dipping to below 4. This might be due to data issues or perhaps unusual sets of low-rated movies from the time. Third is overall pattern. It is the average scores hover around 6 to 7 for most years, indicating generally good ratings over time. These are periods where scores peak high over 7, and especially around 1960 and 1980. The data anomalies is that the sudden dramatic spike or drop could be caused by data errors or outliers, for example, incorrect entries of release years or scores. So what does this tell us in real-world contents? Maybe 3 keywords is that the first, the content quality over time, and data quality check needed, and trends in all viewer ratings. So first is the content quality over times. Fluctuations may reflect a change in the quality or popularity of the movie shows being produced across different decades. The data quality check needs, the unusual dipping and spike suggests it's important to verify the data. Sometimes data error can skew analysts. The trends in viewer ratings is seeing the overall trends help platforms understand viewer satisfaction over the decades, guiding the decisions in content curations and production. Okay, here is the summary. The plot helps us understand how viewer ranges have changed over time, and notice the big drop and spike. These could be data issues or reflect actual shifts in content quality. Such visualizations are useful in business analysts for making informed decisions about content strategy. That's cool. I'll be right back. See you next video.